So this should look familiar because I've given you a version of this already, but I had you only do the back. And then, because we were going to do this week, and then I changed my mind, but then I changed my mind back. So I've changed some of the things, so it's not exactly the same, but it does look familiar. It should, anyway, from something you've seen, but you didn't have to actually do. But at the very top of this, I want you to write notation, fraction, decimal, percent. Those four things need to happen on every question, right? Notation, fraction, decimal, and percent. And I'll explain the notation thing when we go and do some of these examples. This is called conditional probability in tables. Not 100% of this is not conditional probability, but some of it is. But it's all probability of some sort. But it's using the data in the tables and not just straight up having to calculate everything all the time. Remember, we talked about the conditional probability and what do you really, really need to know and be able to do with it? Do you need to be familiar with the formula? Yes. Do you need to be able to use it? Yes. Do you need to be able to force everything you do through the formula? No, because there's different ways to look at things and you need to be able to do it in multiple different ways. Sometimes you have to use the formula. And if you have to use it, then you use it. And we'll look at when those times are as well. But in this case here, on these, you're not going to have to because you have the data. You still need to be familiar with the notation so that you know what it says and to be able to write it correctly. But we need to be able to look at data this way as well. So this says, here are the counts of thousands of earned degrees in the United States in a recent year, classified by level and by the sex of the degree recipient. So A says, if you choose a degree recipient at random, what is the probability that the person you choose is a woman? All right, so what I'm looking for is the probability that I choose a woman. So there's the notation that I'm talking about. You take it from words, you put it into probability notation of some sort. If I want to find the probability that the person I choose is a woman, do I need any other information besides what is given to me in the tables, do you think? The total, yeah, I'm going to need some totals here, right? So I need the total women, which y'all can add up and you have your calculators, but I'll just go ahead and give it to you for time purposes. This is 856, and then the total males is 770, which altogether that is 1,626. Okay. Everybody with me so far? So the probability that I choose a woman is what goes on the top of my fraction? The total women, 856 over what? 1,626, the total, right? So there's my setup. And then I need my answer in a fraction, a decimal, and percent. So I'm going to take this and reduce it. Remember, the calculator will do that for you. So you divide it out. Go ahead and get the decimal first. And then how do you change that back into a fraction? Math, enter, enter. Okay, good. So then this as a fraction is what? Good. 428 over 813. Okay, and then as a decimal, that is 0.526. And then as a percent, that makes it 52.6%. So we're not going to worry about the percent having 3 decimal places. Just use the decimal places you have, and it's fine. So there are 3 different forms of the answer for A. Everybody okay with that? All right, so then let's jump to C. It says, what is the probability that a randomly chosen person is a female or has a master's degree? So that would be probability that person is a female. How do I do or? The U. Okay. Female or has a master's degree. Now, yesterday we did, when it was or, we found the 2 separate probabilities and we added them together, right? And it said that way works. You could do it a different way, but that way does work. That worked yesterday. That does not work today. And so this is another reason why probability is hard to kind of just do a little bit of the advanced and not talk about everything, because everything makes a difference. The reason that it worked yesterday and it did not work today does not work today is that yesterday we had mutually exclusive events. Do you remember those words? These are not mutually exclusive, which means that when I pick a person, could you be a female with a master's degree? Yeah, so since you can be both of the things at the same time, these are not mutually exclusive, which means I can't do the separate ones and add them, or I'm doubling stuff up. Okay, so that only works with mutually exclusive events. But what we're going to do with this one works with both. Okay, the separate and adding doesn't work with both, but what we're doing here will work with both of them. So instead of doing two things and adding them together, I'm going to do this all at once. So looking at female or a master's degree. So do I need to use the total number of females somehow? Yes. Do I need the totals for the degrees, you think? Maybe? Maybe not. We'll see. So I'm going to use the 856. I know that, right? So I have 856, but that's more, I need more than that. What do I add to the 856? 171. Do I also add the 194 since it's right here? No, why not? Because they're female, and we've already used them, right? That's why it doesn't work when it's separately, because if I do them separately and then I add them together, let's just go ahead. Let me give you the total for the master's degrees. It is 365, okay? So I'm taking the 856, because I could be a female or have a master's degree. I only add the 171. I do not add the 365. Because this 194 that is under master's degree is already included in the total that went across this way. Does that make sense? And if I do them separately and then add them, I'm counting the 194 twice, and you don't get to count those people twice. Does that make sense to you? So if I can make a Venn diagram and they overlap, then they are not mutually exclusive, and I have to take it into account separately. So I do just add the 171, because this is all the females, and then this is everybody else that doesn't fall into this category that would be master's degree. Okay? So when I add those together, what do I get? Yeah, 1027, right? So then I take that number, 1027, and what does that go over? 1,626. Good. That's the total. And neither one of these are conditional probabilities, but it is a different way, ways of looking at the total. So then I take that and put that into the calculator. What does that reduce to? It's already simplified, right? It doesn't give you anything else, okay? So I can't reduce the fraction anymore, but what's the decimal? 0.632, which means that is 63.2%. We all good so far? Now let's jump to E. The probability that the person has a master's degree given that they are male. So that really is already in probability notation. I'm going to just shorten it a little bit. Probability of the bachelor's degree given, but I'm going to put the word male because I've used M this morning and I kept saying masters and I was confusing myself. Like every time it came out of my mouth, I knew it wasn't right, but that M, I was just thinking masters. All right, so probability that they have a bachelor's degree given that they are male. All right, so I could do the formula here and figure out the probability of male and a bachelor's degree over the probability that they're male, but I don't need to do all that because of the data that I have. I know what about them? Do I know bachelor's degree or do I know male? Male. Bachelor's degree given that they are male, right? So given the fact that they're male. So you're only looking at the males, right? And so the males, there are 529 that have bachelor's degrees, right? Would I put the 529 over 1626 over 770 or over whatever this total is? Let's see what that total is. That total is 11. So do I take the 529 and put it over 1145, 770, or 1626? What do you think? 770. Because given that they are male, and 529 out of the 770 males have bachelor's degrees. So it's 529 over 770. Reduce that. Does that reduce? No, so I'm stuck with that as a fraction. Then I get 0.687, which is 68.7%. Okay. Everybody okay with that? Any questions? Okay. All right. So do you understand how to look at the tables and how to read through those things? Okay. These are called two-way data tables because you got to look up and down and sometimes left and right. Let's look at the rest of these totals. I know y'all can add, but I would rather make sure that we all have the actual right numbers on this one. 74, and then when you add those, you get what? 42. And when you do these two totals should add up to 1626, and if I add them across this way, that should add to 1626 as well to get your total. Okay, everybody okay so far? All right, now let's flip over on the back. The rest of the data tables kind of take you through the same thing. And at the bottom, the review part, this is the part that I had you do already. These, I've kind of squished them together. It's the exact same questions. But, and I was going to change them so that you didn't have the exact same thing again. But I figured I know you already know the answers. I don't even care about that. We're going to look at the data in a different way. Because what I had you do this first time was make your list of boy, 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 girl, boy, and all that kind of stuff. And then figure it out from there. And of course, when you do that, you have to know how many sets you need so that you make sure you have them all, which is not that big of a deal because you got 3 kids. You got two choices every time you have a kid, so that gives you a total of 8 different possibilities for groupings. And there's nothing wrong with that. That's one way to look at it. So we're going to look at it a different way because different things make sense to different people, and sometimes they will force you down the roads and give you the data that way, and you have to know how to look at it. So let's look at it this way. Let's say that I have a boy, okay? So I have a boy, and then after I have a boy, I could have another boy, or I could have a girl. Then if I have a boy, then a boy, my third child could be a boy, or it could be a girl. Or if it went boy, girl, then it could be boy or girl after that. So that's three kids starting with a boy. Well, if I start with a girl, then I could next have a boy, or I could have a girl. And then if I did girl, boy, this could be boy here, this could be girl here, this could be boy here, this could be girl here. Because one of the issues that I saw with this was that some of you totally understood what to do, but you might have doubled boy, girl, boy just because you didn't realize you already wrote it, because after a while they all start to look the same and there's so many different things you didn't realize you doubled one up. But when you do it this way, it's much easier to figure out a couple of things. First of all, remember with your trees, you just look at the end of the branches, and that right there shows that there's 8 different choices that you have, 8 different possibilities for groups of kids. And then you can make sure you're not going to double them. If you want to, after this, write down boy, 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 girl, boy, that's fine, but it's a little bit easier to do. Boy, 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 girl, then boy, girl, boy, boy, girl, and then you make sure you're not doubling anything and that you get it all right? This also helps when you start looking at the questions that say, what's the probability of whatever, given that the oldest child is a boy? Well, if you know the oldest child is a boy, you get to ignore this entire tree right here. Does that make sense? Because here the oldest child is a girl, so I ignore the entire tree and then go over here. Or if it talks about the middle child being a girl, well, here's a situation where the middle child is a girl, and here's a situation where the middle child is a girl, and you can just look at it from the tree. Okay, so same questions, so it didn't necessarily make it any harder. I don't want you just writing down the answers. Think through it with the tree, even if you like the other way better, just to see it a different way, in case there's a question where they give you a probability tree like this and then ask you questions from it. Okay, does that make sense? It's good to kind of understand a little bit of all the different things, because you never know what they're going to hit you with, and you want to be able to get your way through it. Okay, any questions at all?